Greetings and welcome back to the lab. It's been a little while, so let's build something. Today we're going to launch into the stealth light. This is why I put stealth on the box. These are the circuit boards I mentioned in an unboxing, and here's most of the other parts that we're going to need. Now, if you're not familiar, just a quick review. The idea is I'm trying to light up an area of the yard that has notoriously been very dark, and I can't see if somebody's coming through that part of the yard. There's a walkway there. I can't see on security camera if they're coming through. I want to be able to see, but I also want to provide some pathway light there so that if we go out to throw out garbage, which happens to be over in that area at night, then we can see where we're going instead of stumbling over things. So these are the boards I designed. These are based in part on the Christmas lights. The parts are pretty simple. When I say it's based on the Christmas lights came in two parts, if you don't include the wiring. There were these connectors on I had what I call a coupling board, and that had two of these connectors. So I'm going to kind of simulate it a little bit here. If you can imagine, I've got one here, I've got one there. That was kind of the coupling board, and it also had another connector in the middle that I could connect the ornament to. So the idea was that I could exchange ornaments. I could rearrange things as I wanted. But in this particular case, I want this light to go up and pretty much stay up. So it's not going to get changed around except if something goes wrong with this design and I have to redesign it. So I've got these connectors on either end, so I can put the power into one side, it carries through to the other. I can then daisy chain to the next board over, or if I want to, I can have another board on this side, however I want to do it, but the point is that the power carries through here. So that's what's going on with that. There is a mounting hole in the middle which will allow me to screw it to whatever I'm screwing it to. And then there will be two different kinds of LEDs. One of them is going to be an infrared LED, 850 nanometers, which just happens to be what my camera can see. In case you didn't know, infrared generally comes in two flavors, the 850 and the 940, if I remember correctly. So you have to pick the right one that your camera can see by. It's just the sensitivity of the sensors and what they're tuned to. So I bought a bunch of these, and these are also high power LEDs, so I can drive these to 50 or 60 milliamps each instead of the typical 10 to 20, or 20 pretty much. And these are, I thought these were warm white. I guess they're cold white or they're neutral white. I don't know. They're a bit colder than I expected, but white LEDs, flat top LEDs, which should spread out the light a bit more, and these will top out at about 20. So I did some calculating. I set up a breadboard, and I put some LEDs on it, and I figured out what resistor I wanted to put in there. So just in case you want to duplicate what I'm doing, and I will post this circuit board design up on my website, bitnotes.com. I'll put a link, actually put a link up here. I'll get rid of some of this mess and put a link up there. If you want, you can download the circuit board files and have them made yourself and delivered to you. I've finally just realized that it didn't make a whole lot of sense, except within my own country, if I have them manufactured, then I also have to have them delivered, which has a shipping cost. And then if I then turn around and sell them on eBay, I'm also having to charge a shipping cost to cover my cost of shipping to get them to you. So if I'm shipping internationally, it really doesn't make sense because it's going China to US to wherever it's going out to. So I finally just decided, you know what? I'll put these up on my website. If you like the circuit boards, if you like the projects, you can download the circuit boards, and I'll have plans on the website. Some details, but I'm not going to get too detailed about it because I want you to be able to do what you want with it. And if you like the idea, you can support me because this doesn't all come for free. I do have some expenses in doing this. So if you want to support me, I've got to buy me a coffee. I've got a wish list on Amazon, or you can go to my eBay site and find some of the stuff I have for sale. Not all electronic stuff. There's some photography stuff on there and various things that I'm basically just selling off. So if you want to buy something to support me, great. Thank you so much. And if nothing else, if you want, you can just leave a like and or a comment. That helps the algorithm. So that's enough of self-promotion here. Let's dive into this. Oh yeah, sorry. Two more things. One, let's look at over here. Let's look at, I figured out with the white LEDs, and for each string of 4 LEDs, I want to have a 62 ohm resistor, because that'll give me 12 milliamps per LED. Now this is a 12 volt system, so if you're putting 4 of them together in series, you need your voltages to kind of match up. But 62 should be a good medium, and I happen to have a bunch of 62s because I needed them for another project at one point and ordered up like 100 of them, and then I kept using them, so I ordered up another 100. So I got quite a few of those ready to go. As far as the infrared, this is the tricky one. Infrared is a lower voltage LED. It takes less voltage to turn it on. So I can actually fit a lot more of them. Now originally I designed this board. The infrareds are going to go in the middle rows on just on either side of the mounting hole. I provided for 9 of them, but as it turns out, in this case, the infrared LEDs that I ordered, I can only put 7 of them before the voltage gets too high to be able to drive them at a high current, which means if I put 9 of them in there, then I can only drive them to like 10 milliamps, which really doesn't provide me the brightness I need for infrared. Oh, and if I hadn't mentioned it, the reason why there's both white and infrared is that I have visible light and I have invisible light, the infrared light. The infrared light is for at night and for the camera's benefit. The white light is visible light, and it's for people walking on the path so that they have some light. So this times 7, I ended up deciding to do a 22 ohm resistor, and that should get me 47.5 milliamps. And mind you, that is not per LED, that is across a string of LEDs. So the white LEDs are going to go in this 4, and that 4, that 4, that 4, that 4, that 4. The infrared is going to go all the way across like this and all the way across like that. But what I'm going to end up doing, since I can only use 7 of the 9, I'm going to have to put a jumper on the ends. So that will take care of completing the circuit so that they can run. So if you add it all up, you're going to end up with, on the top row, you're going to end up with 12 plus 12. The next row you're going to end up with 47.5. The next row, again, 12 plus 12. Next row, 47.5. And the next you're going to get 12 plus 12. So what's that going to work out to? 24, 48, 72 plus 95. You're at 102, 162, if my math in my head is correct. 162 milliamps to drive this board. I have a power supply that's capable of a little over 2.5 amps, so I can drive at least 10 of them. That's pretty good. So we'll see after we get the first one built what it ends up looking like. Let me just get to building. First thing I'm going to do is I'm going to put these pieces on, and just so that I can actually test it as I go. And then I'm going to start mounting the white LEDs, and then I'll keep coming back as I get each section done and show you the progress. And if something goes wrong, I'll also let you know. So here I go. Didn't I just say if something went wrong, I'd let you know? I'm honest about my projects here, and if I'm not going to give you the full time-lapse experience of everything and just jump from section to section, I should point out that with these connectors, you actually want the metal part facing outward, and that's what I did. I'm hoping that's coming through. So I've got to desolder and resolder that one. Back to it. Alright, it's time to do a quick test here. I've got the first 4 white LEDs in, and I don't want to permanently mount the resistor yet because I want to be able to check the infrared when I do that, and I'm afraid that on camera the white is going to swamp out the infrared when I try and do that. So I'm just going to temporarily stick this resistor where it's supposed to go, but I have a power supply here. I'm going to try and connect up. That should give me 12 volts into this connector, which would also mean 12 volts over here. And if I'm right, there are room for 3 resistors along this side, and they correspond to the first half of the first row, the first half of the third row, and the first half of the fifth row. So let's give that a try with the 12 volts that are on here, and if I can line this thing up. Whoa, that is bright. Believe it or not, that's 12 milliamps. Okay, so we know that the system is working. I'm going to go ahead and get the first row of infrared in there. Or actually, I'm going to finish up the first row of the white LEDs, and then I'm going to do the first row of infrared, and then we'll demonstrate that. So I'll be right back. Okay, now, depending on how sensitive my camera is, I've dropped in a resistor right here. For the infrared, there's 2 up here and 2 down here, so you can actually put, because they're higher power, I wanted to allow resistors in parallel to share the dissipation of heat. So I've set that up with the 22 ohm that I calculated. As far as I know, the 22 ohm should work. I did the calculations on it. It should be about 1/8 of a watt. So these are supposed to be quarter watts, so even if they're 1/8 watt disguised as quarter watt, it should still work. So I'm going to plug it in. Now you're either going to see a bunch of light. Actually, let me move this up a little bit differently here. You're either going to see some infrared light, which will just look like dull white light, or you're going to see a red glow, which is what it comes up visible as, but it's a much dimmer red glow than with the white LEDs. So let's see which one we get. I'm not going to know until I actually go through this recording. Okay, I can see a dull red glow, and they are all lit, which is good news. So we're off and running on that. So now what I'm going to do is complete the rest of this following the same basic procedures, and we'll come back at the end and see what the finished light ends up looking like. And just like that, it's several days later. I had a problem, but then I figured it out. It turns out when I had a problem with this not being as bright as I thought it was going to be, and then I had to do 7 instead of 9 of the infrared, various different things going on. Ultimately, the problem I had was that it seemed like I couldn't do the white LEDs and the infrared LEDs at the same time because there was like a voltage clamping issue or something. I finally figured out what it was. It was the power supply itself. Under load, it was pulling down way below 12 volts. It was going down to about 9 volts. And because of that, I wasn't able to drive all the LEDs. So before I figured this out, I decided, okay, we'll make, lemons into lemonade here. And I decided, okay, I'll just do only the color LEDs, the white, so to speak. And so I did that. And when I hooked it up to the other, was my temporary power supply. When I hooked it up to the one outside for what had been the Christmas lights and got everything set up to go, it was bright. And it does a beautiful job of lighting up. I'll show you what it looks like at night now. But I never really got to test the stealth function of this, which the whole idea was supposed to be that if I put up the white LEDs so that it's visible light, then it gives you some pathway light, which it is doing and doing beautifully, but it's not bright enough on its own for the camera to be able to pick up. So what I ended up doing was I ended up building two of them with the white LEDs, the visible LEDs, spacing them out nicely so that they fill in the area with light. And so if I happen to need to go to the garbage can to throw something out at night, I can see where I'm going. And then I set up another one with the infrared, so a third circuit board with the infrared, and that is projecting towards the gate. If you look at the picture, you can see it's opposite the gate on the underside of the roof there. So that is set up, and it is handling that area of the yard beautifully. But what I want to do is I want to go ahead and build it the way it was intended, knowing that it's going to be hooked up to a reliable 12-volt supply, and we'll see what that ends up looking like. I'll be right back. All right, it's a little bit later, and I've been working on building the actual stealth light, and I've run into problems like I picked the wrong resistors. So I was pulling like I was trying to push like 170 milliamps through each one of these LEDs, which might explain why one of them went bad on me. And so I had the entire top row was not working because that one died. I used a button cell just to verify each LED. Anyway, I'm going to plug this thing in from video that I've already watched back for this video. I already know that what you're going to see is going to be a white light, whereas I'm seeing it as red. So that's just the infrared, and that's because the camera that I'm using will pick up the infrared. And it is probably going to be very bright, which is why I don't have the studio lights on right now. I just have some general lighting on. So let's turn this on and we'll see what it looks like in video. And if I hook it up right, there we go. Now that should be connected. I'm going to go look at the camera. Wow. That is creating a glare over here. That's odd. What happens if I turn it? Yeah, alright, well, then if I turn it that way, I'm kind of hitting the sensor. Alright, well, anyway, that's what this looks like. Now I got to go and finish up with all the white lights, and then you'll be able to see the whole thing. Okay, this has been an adventure, but I finally got everything hooked up, and I'm going to demonstrate. It's going to get bright. I don't know what that's going to do to the camera, but if it's too bright, I'll turn it down in post. But here we go. Let's see what the stealth light looks like. Ooh, a little hard to look at if you're actually sitting here. But that should give you an idea. That consumes about 190 milliamps. It started at like 183 and it was climbing, I think, as the resistors start to heat up. And, well, they're not too hot from that, but I do know from some testing while I've been trying to get this all working that they do heat up. But I think I'm good. I think I'm within spec on the resistors. I've got some other ones running outside that have just the white, and one that has just the infrared. So I know that it's functional. I've got this working now. I'm going to have to put this up and see how this compares to the ones that I put up when I thought it wasn't working. And we'll be back in just a moment. And just like that, I think I'm finally going to call this a success. This is one of the boards, but right now what I have outside is 3 stealth boards, 3 stealth lights mounted under the eaves to provide light in that area, and it is now bleeding over into the area that was already kind of well lit. So I could add more, and I'll explore that later. I've got other projects I want to do, but this was the goal here, was to lighten up that area so I could see what was going on, so there would be path lighting when people went out to go take out to the garbage, or if animals decide to make a little excursion onto that pathway. So I'm going to go ahead and show you first a picture of that I took actually while I was on the path looking up towards the lights, but I didn't want to blind the camera, so it just kind of gives you an idea how well lit the place is, independent of what the security camera is picking up. Then I will show you a picture of what it looks like on security camera, so you can kind of see what it looks like. This will be low light at night, but not night vision yet. And then I will show you the night vision, so you can see it gets to be a little bit more focused light. And that's just down to the LEDs themselves are more focused, so the light overall is focused. The white LEDs tend to be less focused, and that was intentional. If I could find infrared LEDs that had a flat top, or maybe at some point I'll try chopping the tops off of them. The problem is when I've tried to do that in the past, you end up getting a very uneven pattern out of it because it's really hard to chop it off. You have to just kind of break it off. The plastic lens on the top, you have to break that off, and it doesn't work out that well. You can sand it down, but then you end up with a frosted top. So I'm not sure what I might do there, but I'm happy enough with this right now that I don't want to mess it up. So this has been a long journey trying to get that area lit up, and I kept trying to do it with solar, and that just wasn't working. I tried it with some 5-volt options that I could power with like a USB or something like that, and then just go out and recharge it. I got batteries from old devices, lithium-ion batteries, 4.2 volts, but I could always step those up to 5 volts. I could probably step them up to 12 volts, but then I have to recharge them that much more often. So it really just kind of came down to, I can easily run a thin wire from inside the garage to through a vent in the side of the house that just kind of vents the garage so you don't end up with air pressure issues. Really simple, great. Just run a wire through that and up to the lights, and I could probably make it look neater. But it was just, let's see if we can make this work. And then I got a chance to do the Christmas lights last year. That was really fun. I'll probably do it again this coming year, but we're in January as I record this, so that's off in the distance. I've got other projects I want to work on. I wanted to wrap this one up so I can move on to the next one. But again, I'm a happy camper. And thank you so much for staying with me on the journey.